Alright, and welcome to the product of a logarithm. Now, this is the rule that we're going to be using for this entire video series, that if we have a log of base b plus another log of base b, whatever is inside the logarithm, you can take those two things and you can actually multiply them together. You can rewrite it as such. So for instance, here we have a log of base 3 of 7x plus a log of base 3 of 6 is equal to 5. Notice that these both have the same bases of log base 3. We can rewrite this as log base 3 of 7x times 6 is equal to 5. Well, 7x times 6 would actually give us 7 times 6 is 42x is equal to 5. And from here, what is our property that allows us to get rid of a logarithm? Well, if we have a log base 3, we're going to raise everything up to the exponent of whatever that number in the base is. So 3 to the power of log base 3, those things cancel because a logarithm is the inverse of an exponent. Now what we do to the left, of course, we have to do to the right. And so we now have 42x is equal to 3 to the power of 5. Notice though, 3 to the power of 5 is really like saying 3 times 3 times 3 times 3 times 3. And so I would just encourage you to use a calculator for this. If I go to this symbol lab right here, and let's see here, let me just go ahead and delete everything. And I would just to go ahead and say, you know what is 3 to the power of 5? Go. It should give us 243. Okay, so we know that 3 to the power of 5 is 243. Now from here, we simply have to divide both sides by 42, and of course, x would be 5.785, or let's just call that 5.79, just rounding out to 2 decimal places. Okay, let's go ahead and move on to example number 2. Okay, for example number 2, we have 2 equals the log base 8 of 3x minus 6 plus log base 8 of 2. Now how in the world would we rewrite this? Well, we can write it as 2 equals the log base 8 of what we have on the very inside there, 3x minus 6 times 2, what we have on the inside of our second logarithm. Now notice here, this will actually get a little bit complicated because we have a parentheses times a single digit. We're actually going to have to distribute that 2 into both numbers. So 2 times 3x is 6x minus 2 times 6 is 12. Now at this point, how do we get rid of the logarithm with the base 8? Well, since it's a logarithm with a base of 8, we're going to raise it into the exponent of that same number. We say 8 to the power of log base 8. Those two things cancel. Now what we did to the right, we have to do to the left, and ask yourself, what is 8 squared, or aka 8 times 8? And of course you'll get 64 is equal to 6x minus 12. And from here this should be fairly straightforward. We add 12 to both sides. 64 plus 12 is 76 is equal to 6x. I divide both sides by 6, and it appears I can probably divide both of these by 2. So let's see, half of 76 would be, I believe, 38 over half of 6 would be 3, and you could reduce it as such. Here, if you wanted to do the decimal and do 38 divided by 3, let's see, 38 divided by 3, that would be, of course, 12.67. I am okay with either. Alright, I hope this helps, and I'll catch you in our next video series.